All right, this is lesson 6.1, first lesson in chapter 6. We are working with quadratic equations and we're solving them by factoring. Factoring is that skill now that I have really tried to stress to you guys as being arguably or not arguably the most important skill you're going to learn in grade 10. Okay, so it's just going to keep coming up and up and up. And if you look at the grade 11 title of the course, it's called functions. And functions are the things that we're factoring. That's exactly what that is. Whenever you have a degree of 2, you have a function. Okay? So what is a quadratic equation? A quadratic equation, it's an equation that after any necessary simplification can be written in this, which is called what? What type of form is that? Only 2 people know. Put your hands up. What form is that? Ax squared plus bx plus c. Talked about it for a long time yesterday. Axis, were you awake? Standard form, good job, yeah. Standard form, right? That's standard form. We have 2 other forms that we're familiar with, which are, Rudy? Nice. Saw it up there? Good job. Cheater. All right, example, so negative 5x squared. What's this graph gonna look like, Josiah? How's that parabola gonna look? It's gonna look good? No, I want you to describe it based on the a value. So what is the a value?
5x. We're not the example.
Yeah, right here.
It's 5. 5x squared.
It's actually a negative 5. Yeah, so I want you to describe the shape of that parabola, Josiah. What does it look like? The a value is negative 5. So if its a value is negative, what does the parabola look like? Yeah, it looks like an N, okay. And now the a value is a 5. So what is it going to look like? Is it going to look like narrow or is it going to look wide?
Narrow.
It's a 50-50 shot. Yeah, it's going to be narrower, right? Because it's a 5, it's going to look stretched. So our step pattern is going to be multiplied by 5, down, right? Instead of 1, 3, 5, it's going to be 1, 15, 25. So this thing is going to look like this. Very, very, very skinny and going down. That's what this looks like. Okay? That's what standard form, that's really the only thing we know from standard form. Okay, so we can see here that if we were to factor this, we get this, which is not something we could do manually. We'd have to use some sort of software to do this because we have a decimal value here, so that's not going to be something that we can figure out. But nonetheless, it factors to that. We can see here equals to 23.7. We then, non-examples would be these values because our degree is not 2. In this case, it's 1. In this case, it's 3. And in this case works. X squared minus 3x plus 4 and negative 5 squared plus x plus 3. This is just a straight line, so this does not work. Okay, this one would work. All right, so features of a quadratic equation. It has degrees of 2 and has a single unknown. All right, so that's important to understand. It has degrees of 2, so that is that number, the square, okay, and has a single unknown. So you can't have like x squared y plus 3xc d plus 7. That is not going to be a quadratic because it has more than one unknown variable. Okay, it has y, it has c, it has d, it has x. That's not going to be a quadratic. Quadratic is going to be in this form, right? Something like that, where we have x as being the only unknown, we have a degree of 2, that's a quadratic. Okay? The root of an equation now is the same as the solution. So, actually, there's 4 names. So x-intercepts, zeros, roots, and solution. They're all the same thing. Remember I told you yesterday, I wrote them down here at the bottom, there was 3 of them for those x-intercepts. There's actually 4 names for them. They're also called the solutions. And why would they be called the solution to the equation? Well, because you solve for x when y is 0. So you're solving, you get a solution there. Okay? So the roots of the equation, the same as the solution, the value of the variable that makes an equation true. Okay, so we will learn how to solve quadratic equations using the following strategies. So factoring, this is what we've been learning now for the whole chapter, chapter 5. Some quadratic equations can be solved by factoring. Okay, so this is if we have those perfect numbers where we can come up with 2 numbers. This would not work for us because we have a decimal already value here, so that's going to be tricky. Completing the square is something you haven't learned yet, but we're going to learn. And this works for all quadratic equations, can be solved this way. Okay, and this is going to help us with establishing vertex form as well. Okay, so that is going to be something we're going to learn in chapter 6. And then quadratic formula, this is also another way that we can solve all quadratic equations by using a simple formula. All right, so I say simple, but it's kind of complicated, the formula, but we're gonna learn it this way. And it's nice to have these 2 other methods because you can always use them to double check your factoring. Okay, factoring is maybe the easiest, depending on how good you are, how much practice you have factoring. But there was going to be 2 other methods we're going to learn in order to solve these quadratics. Okay, completing the square and the quadratic formula. All right. So if 2 factors have a product of 0, then one or both must equal 0. So let's talk about this statement here. This is very important because this comes down to how we solve for the roots. Okay? If a quadratic is already in factored form, so we have this, x minus r, x minus s equals 0, set each factor equal to 0, and then solve for the unknown variable. So if we have 2 numbers multiplied by each other, and one of those numbers is 0, the product of both of those numbers multiplied has to be 0, right? Because if this turns out to be 0, then it doesn't matter what x minus r is, this equation is going to be true. Do you guys understand that? It's an important concept you need to understand why and how we can solve this. Because anything multiplied by 0 is going to be 0. So if x minus s is equal to 0, then this whole thing is true. So therefore, we know if we can solve for x where x minus s is equal to 0, in other words, where x is equal to s, we know that this whole equation is true. Anybody confused by that? Because I'll explain it again if you need to.
Can you explain it again?
I will. Okay, so if you have 5 times 0, this is going to be equal to what? 0. If we have 5x squared minus 3x times 0, what's this going to be equal to? 0. If I have 10yabc times 0, what's this equal to? 0. So any value of x minus s, any value of x minus r times 0 is going to be equal to 0. Did you guys agree with that?
Yeah.
So if that's the case, then x minus s equals 0 would be correctly solving this equation. Okay, because if x minus s is 0, this whole equation is going to be 0. You guys understand that?
What if x minus r is 0? Is that the same thing?
Right. Yes. So conversely, or additionally, if x minus r is 0, then it doesn't matter what x minus s is. This whole thing will also be 0. Does that make sense? That's the exact reason why we can go from this formula into 2 equations, x minus r equals 0 or x minus s equals 0. Do you understand now why this gets broken up into 2 equations? That if either of them are true, that solution works? You guys understand that? This is important, right? Because you can't. You're like, oh, sir, you just had this one equation. Now we're working with two separate equations. You need to understand why. The whole reason is anything times 0 is 0. So if we can find one of these things equal to 0, we're solving the equation. The other one is equal to 0, we're also solving the equation. Yeah.
If x is equal to r and equal to s, can you do x minus x equals 0? Or would that be completely?
Sorry? Yeah, this would be x equals r and x equals s. Yes, that would be the solution. So for this equation, if x is r and x is s, then this is going to be 0.
So would it be different from x minus x equals 0?
If it was like x minus x
Yeah, equals 0.
equals 0, yeah, this would be 0 equals 0. I don't know why you would ever have this. These would just cancel out into 0. Yeah. Okay, let's look at some examples here. This should make more sense. Okay, so it says solve the quadratic in factored form. So it's already factored for us. So this is super easy. So that whole explanation I was telling you is just so that you can write this or this. I just want you to understand that if this is 0, then this equation is true. If this is 0, this equation is also true. So you end up getting these two equations. Students sometimes don't know how did I go from one equation to two equations? That's what I'm trying to really reinforce in your mind. Like, it's possible because anything times 0 is 0. Okay, so now that we have these two equations, we can solve them separately. X is going to be equal to 7, and x is going to be equal to negative 11. Okay, and everyone, I hope, is very familiar with why that's the case, right? We're moving the 7 over to the other side, we're moving the 11 to the other side, and we're changing the sign, right? Any questions there? So once we have something in factored form, it's pretty easy, right? We just set each bracket to 0, so we get x equals 5 for this one. The other one, 2x plus 7 is equal to 0. We're going to move the 7 over. We get 2x equals negative 7. And then we get x equals negative 7 over 2.
So, sir,
Yep.
once we break up the equation, we just solve for x.
Yes. Yeah. And what is x on the graph? KG. Sorry? Yeah, the zeros. What are the zeros?
The solution.
The solutions. What are the solutions? The roots. What are the roots? The x-intercepts. They're all the same thing. Okay? The one that maybe makes the most sense is x-intercept, right? They're the x value where the parabola crosses the x-axis. Okay? All right. Next one. We got already nice and set up for us. It's already factored. Don't get used to this because you're not going to have questions like this very often. But we get 3x equals negative 5. And then x equals negative 5 over 3. Additionally, we have negative 4x plus 2 is equal to 0. Negative 4x is equal to negative 2. X is equal to 1 over 2. Any questions there? Question? Josiah?
And so, sir, for the final answer, we would just box the x.
Yep, that's the answer. Those are the roots right there. Okay, next question. Here we have not bracket times brackets. We just have negative 7x here. You know what I could do here? Does anybody know? Jaden, you have an idea what I could do here? What would my two equations be here based on this? Deal with the one in the bracket first because that's what we've been doing, right? What would I write? Yep, 4x. Yep. 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 Now, how do you solve this? Yep. Negative 3, good. Okay, now? Excellent. Okay, now what do you think for this side? It's different. We haven't seen this before, but what would you think? No. You have to set the negative 7x to what? To get the whole equation to equal 0, what do I need the negative 7x to be? Let him think, guys. He doesn't need any help. He can figure this out. What times this would be 0? What does this negative 7x need to be? No. You're setting both of these equal to what? Yeah, you're going to set the negative 7x equal to 0. Right? Because if that's true, Jaden, then this whole expression is going to be true. No matter what the 4x plus 3 is. Right? Because you're going to have this term 0 times whatever is equal to 0. Okay, so now how do I solve this? I want to isolate x by itself. So what can I do to both sides? Divide it by not x, but what's in front of x, right? Negative 7. Negative 7. So we get x equals, what's 0 divided by negative 7? 0, good. Okay, so these are our two x values. So this is interesting, right? The x-intercept is 0. So that means when y is 0, x is 0. So this particular parabola opens down and it crosses through the origin. It crosses through 0, 0. So the very middle point of that xy plane. Yeah? That.
For example 3.
Yep.
What if you put x1 equals negative 5 over 3, and then x2 equals 2? Would that be wrong? If you put I'm saying it in all one.
Okay, sorry. Ask me again. What if you put what?
x1 equals negative 5 over 3, and then x2 equals 1 over 2. So when you put it like with 1 equals something.
Like you want to write. Like that?
Yeah.
I guess you could, but we typically don't denote like 1 or 2 because who's to say which x is the first one, right? Because when you're solving, you're not going to necessarily solve x1 is not always going to be the left x, x2 is not always going to be the right x, so there's no point in putting the 1 or 2 at the bottom. I wouldn't necessarily mark it wrong, but it's just like it's kind of meaningless because you don't know the order, so there's no point in putting that. Yeah.
Sure, if you multiply like negative 5 divided by 3 by half, it's 0. Is that the same?
If you multiply what?
Negative 5 over 3 by 1.5.
By 1.5?
Because didn't you say like one of them has to be 0? Or if they both multiply equals 0?
No. I think I'm losing you now. I don't even understand what you're asking. Why would I multiply this by 1.5?
Isn't one of them supposed to be like 0?
They're both supposed to be 0.
Oh.
Both of these terms are supposed to equal 0. Do you see what I did? I set this term equal to 0. I set this term equal to 0. Do you understand?
Yeah, but
Any other questions? Yep.
How do you know the term is 0?
Okay, that's what I've been trying to explain the whole time. If you have this term is equal to 0, then anything times 0 is 0. So if this term is 0, then this whole equation is true.
So you just plug in the x to the term.
No, I don't have x. I'm solving x. Like if I plug x back into here, I'll get 0. Yeah. Yeah.
oh.
I will. Yeah. You will. If you take this and plug it in here, you're going to get 0. If you take this and you plug it in here, you'll get 0. That's the whole point. That's why I'm solving it. Because I want to know the x value that makes that bracket term 0. Make sense? Yeah.
Why is not 1 positive?
Because it's negative 2 divided by negative 4. So it's a negative divided by a negative, which they cancel. You're right. My bad. Thank you, KG. This negative 4 moves over. It would be negative 4. It would be positive 4, and this negative 2 is still negative, so you're right. Sorry about that. Good catch.
So, what? Wait, so how did that?
Oh no,
That doesn't make sense.
that's wrong. That's wrong. Sorry.
Then it make the.
Sorry. I'm not moving the 4 over kg. I'm dividing by -4. Let's do this one again. Here. I'm confusing you guys now because I'm getting a little messy here. Let's do this one more time. -4x plus 2. kg confused me here. -4x equals -2. You with me so far, kg? Okay, now divide both sides by -4. You get x equals 2 over 4 x equals 1/2. Does that make sense? Say, I'm not moving the 4 over, I'm dividing by -4. Okay? Alright, any other questions with those? Alright, this was the easy stuff. This was the easy stuff here, hopefully. It's going to get harder. Okay, example 5. Write a quadratic equation in factored form for each situation. The roots of the equation are -4 and 5. Douglas is going to figure this out. So we need to write a quadratic equation in factored form. So what does that look like, first of all? Who can help Douglas out? Tell us what quadratic form and quadratic equation in factored form looks like. Factored form, I'm going to write it up here. Y equals what?
Oh, you're talking about what the factor form is?
Yeah, what is it?
Oh, x minus r.
Yes.
So practice with it. And then x minus x.
Very good, Chenier. Excellent. Yep. So that's the factor form. So now Douglas is going to tell us what is the roots of the equation that are -4 and 5. What's the equation going to be for the quadratic? So y equals
X plus 4.
x minus 4 and
X plus 5.
okay. Wrong. Why is he wrong?
Hey, sir. Isn't it supposed to be X plus 4?
Yes. Correct. He changed his mind. And
Minus 5.
nice. You guys understand why? Does everyone understand why?
Nah, I don't understand.
Okay.
That's right.
It's great to ask if you don't understand, Andrew. So very important here. It tells us the roots of the equation are -4 and 5. So that means x is equal to -4 and x is equal to 5. Would you agree with that, Andrew?
Yeah.
If those are the roots, right?
Yeah.
Okay, but now to go to factored form, I got to put these kind of back together, right? I got to go x plus 4, right? And x minus 5 to get them equal to 0. Does that make sense?
Yeah.
Now, do you understand
Yeah.
why he did that?
Yeah.
Okay. All right, Stefan, you're going to try this one. The roots of the equation are 2 and -3. What am I going to write?
Bracket X minus 2.
Yep.
And then go bracket X plus 3.
Excellent. And I would just put y equals in front. Because this is a quadratic equation, so we need to know that's the y value, right? Y is describing, how this parabola goes. All right. If a quadratic equation is not in factored form, first write the equation in the standard form, then factor a left side. Next, set the factor equal to 0, and then solve for the unknown. So here we go. Not in factored form, not even in standard form. Jadane, can you put this in standard form for me? Nope. Not y. There's no y here. You're just... Sorry?
ax squared.
No. You know what a is. It's 1. I'll help you out, Jadane. You just got to put the 3 on the same side as these two variables and set everything equal to 0. Can you do that?
X squared.
Yeah.
2x minus 3.
Yep.
Equals 0.
Very good. Okay, so now we've moved it to standard form. This is standard form. Now, who wants to go ahead and factor this? Who's been practicing the factoring? Yep. Yep.
I would move the negative 3 over. Oh, factors.
What?
Sorry, I'm not sure. Sorry, I wasn't listening. Oh, okay, so we take out the x.
Do we want to do this?
No,
Decomposition. Okay, let's go old school. All right. So what do you want to do? You want to do the product and the sum?
yeah, the product would be just negative 3.
Okay.
And the sum would be 2.
Okay.
So I would use 3 and 1.
Okay. Positive 3 and 1 or negative 3 and 1 or positive or
Positive 3, negative 1.
positive 3 and negative 1. Those add up to give us positive 2 and they multiply to give us negative 3. Yeah, that's right. So then what would I write?
X squared.
X squared. X squared.
1 of the minus 3. So plus x minus. Oh no, minus 3.
Minus 3? Okay.
So I should say x. That lost it.
You lost? Okay. I'm going to save you. Who wants to save him? Josiah? Yeah, x plus 3. Yeah, he's done all the hard work. And, yeah, x minus 1 equals 0. You're done. Should not have been that hard. This is one of the easiest equations to factor, I would think.
Vertex points.
Sorry?
I said vertex points.
What about it? Yeah, it doesn't look like today. Not today. We're gonna get to it in this chapter, though. You getting bored of this factoring stuff?
No. I think I need to learn more skills.
Okay, it says here, next set each factor equals 0 and then solve for the unknown. So what am I gonna do next? Yep.
X plus 3 equals 0.
Yep.
And then you x minus, x equals negative 3.
Yep.
Then you do x minus 1 equals 0. And then x equals 1.
All right, done. All right, that was underwhelming, let's say. This one, who can factor? Oh, we'll go down here. Yeah, who can factor this one? You are nervous about factoring. It's a big problem. You want to try, Josiah? This one? Okay. Sorry? I can't hear you.
2, right? I'm gonna tell you what's right.
Okay, 2.
Alright, so 2, then x, only 2, y squared. And then minus 3x plus 1 equals 0.
Done?
That's not right.
No.
That's not right.
No. Anyone else want to try? Factor it? Not really close, Josiah. We got to factor it, right? We need something, 2 brackets. There's 2 ways to factor this. We can either use decomposition or we can use the magic X or the crisscross method. Hold on, we're gonna try someone else. Hold on. Go ahead. I'll let you try the next example. Go ahead, Douglas.
X plus 2.
X.
With the brackets.
X plus 2, okay.
Bracket x plus 1.
Like this?
Yeah, equals 0.
Okay. That was quick. We can try. Let's see. Let's expand this out. So we get 2x plus 2x, sorry, x squared plus 2x plus 1x, so plus 3x, and then we get, unfortunately, plus 2. So this does not work either. Yeah, Teody.
Crisscross method.
Okay, I like it. Yep,
And then we would fit 2x.
yep,
And then x.
yep.
Then we would use 1 and 1.
1 and 1.
Yeah.
Okay, yeah, 1 and 1, yep. Now what?
would equal
Okay, equal. Sorry?
it would equal x plus 2x. And that would equal 3x.
Yep. Okay, so that seems to work, right? You only just got to tell me what the sign is. What sign in here and what sign in here?
Both of them are positive.
Both are positive?
Yes, sir.
Okay, let's try it out. So you telling me that this is the answer. I think he's very close, right? That's what he's come up with. So let's expand it out. We get 2x squared plus 2x plus x plus 1. So we get 2x squared plus 3x plus 1. Ooh, very close, but we have a negative and we have a negative. So incorrect. Today, you guys really need to practice factoring. This is not a particularly hard one, but you need to know how to do this. Go ahead, Jadain, you want to give it a shot?
Negative.
Okay.
Bracket x minus 1. And then bracket 2x
Yep.
minus 1 equals 0.
Let's try. Multiply it out. 2x squared, negative x, negative 2x. We get negative 3x, and then we get plus 1. That does not work either. What?
That doesn't work.
Nope. Anyone else? Wow, I don't know that I've done my job here. We cannot factor this. Let's everyone pay attention now, okay? I'm going to show you 2 ways to factor this, okay? Okay, the first thing I'm going to do, a lot of people seem to be struggling with this. This negative sign in front of the a value. It's giving everyone a lot of trouble. Lucas, you gonna deal with it? Yeah, go ahead.
Nice full straight.
Sorry?
Let's do the first one.
If you don't want to, tell me what you're doing.
That's first analysis. 2x
Yeah?
and minus x,
Okay?
then minus 1 and 1.
Okay?
Positive x plus
Sorry?
that.
Okay, tell me the answer then, if you just want to go from here to here.
Bracket
Yeah?
2x
Yeah?
minus 1
Yep?
bracket
Yep?
x
X
plus 1 or
pl-
minus x plus 1.
minus x plus 1? Okay, let's check it out. We get negative 2x squared. We get 2x plus x plus 3x, and then we get minus 1. Very nice. Dun, 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 he did it. Crisscross for the win.
Crisscross applesauce.
Now, what you could have done, if this negative is really giving a lot of you problems,